All right, here we go. Welcome back. Today we're going to talk about solving absolute value equations. So it's going to focus on absolute values, obviously something we learned a little bit about in section 1. So let's take a look at how we're going to solve absolute value equations. All right, let's get started with something we looked at in section 1, and this is just a simple absolute value of a number. Okay, so what is an absolute value again? Remember that an absolute value, when you see these absolute value bars, it describes how far away a number is from 0. So I could say, for example, what is the absolute value of 5? I want to know how far away is 5 from 0 on a number line. Well, 5 is only 5 units away. Similarly, if I say the absolute value of negative 5, what would that be? How far away is negative 5 from 0? We get the same end result and we get 5. So what that means is that the absolute value of both 5 and negative 5 end up giving me the same answer. So if I give you, for example, what is the absolute value of y, what would y need to be in order to give me 8? The thing you got to remember about this is that there are two potential solutions. Y could be equal to 8, or y could be equal to negative 8, because both those answers would result in 8 if I were to take the absolute value of them. Okay, so what we get here are two solutions. So y could be 8, y could be negative 8. All right, next one, let's say the absolute value of p is negative 6. Now, the thing to remember with this one is, can I take, let's say, for example, the absolute value of 6 and get negative 6? Or say the absolute value of negative 6 and get, negative 6. So remember with this one, the absolute value, the shortcut thing to remember is that the absolute value of a number will never result in a negative answer, because we're simply describing a distance from 0. We're not describing a positive or a negative along with it. It's just simply a distance. So the key thing here is that the absolute value of negative 6 can never occur. So these answers can never occur. So what we get is no solution. Okay? So key things here to remember, that you're always going to have it really turn into a positive number. It can never be a negative number, and that you're always really looking for two solutions. So remember, whatever's inside this absolute value bar is always going to make it positive. All right, so today we're going to take this a step further. We're actually going to start solving absolute value equations. So an absolute value equation is going to look something like what we have here in this example. So I have the absolute value of 2x minus 3 equals 5. So notice in the end, really, I have the absolute value of something gives me 5. Well, we should kind of know, we could kind of anticipate what needs to go inside the absolute value in order to give me 5. If you think about it, either 5 or negative 5 would result in 5 as the absolute value. So what I'm trying to say here is that the absolute value of 5 is 5, and the absolute value of negative 5 is 5. So that means whatever's inside these absolute value bars, 2x minus 3, whatever value that we have for x can result in either 5 or negative 5, because the absolute value of those two values of 5 and negative 5 will give me 5 in the end. So what I'm going to try and do here is I'm going to try and set this up so that I can think ahead of time, whatever's in these absolute value bars could be equal to 5 or negative 5, because both, when I take the absolute value of them, would give me 5 as a result. So here's how we're going to set this up. We're going to take whatever's inside, 2x minus 3 in this case, and we're going to set that equal to one of two things. First of all, 2x minus 3 could equal 5, because the absolute value of 5 would give me 5 as an end result. Okay? Similarly, 2x minus 3 could equal negative 5. Because both of these, 5 and negative 5, when I place them inside the absolute value bars, they're going to give me 5 as an end result. So what I'm doing here is I end up having to solve for two separate equations. So let's go ahead and do that. This one I'd have to add 3 again to both sides, boom, and I get 2x equals 8, and therefore divide by 2, you're going to get x equals 4. Over here, if I add 3 to both sides, again, same process, I'm going to get 2x equals negative 2. Divide by 2 again, you're going to get x equals negative 1. So what I get here is two solutions. What I'm saying is that if x is equal to 4, I'm going to result in 5 inside my absolute value bars, which is then going to give me 5. And if x is negative 1, when I plug that in for x here, that's going to give me negative 5 inside the absolute value. But the absolute value of negative 5 is also 5. So what we get here is two solutions. Both these solutions make this equation true due to the absolute value of that number. Okay, so here are the steps, basically what I just did in that previous example. So the first thing, we didn't have this in the previous example, but the first thing we're going to do is we're going to try and isolate the absolute value bars, meaning we're going to take anything that's outside the absolute value and we're going to move it to the other side. In this case, we're going to treat the absolute value almost like its own variable, meaning we're going to solve for it like we would x. Once we have the absolute value by itself, then we're going to set whatever number is inside equal to the number on the outside and its opposite. Okay, so set whatever's inside the absolute value bars equal to the number and its opposite. That means the positive or the negative. And then what we're going to do is solve both equations. So here we go. Let's take a look at a quick example here. I have 2 times the absolute value of x minus 8. Now this is multiplication, 2 times, plus 3 equals 15. So follow the steps carefully. Step 1 says that we are going to take anything on the outside of the absolute value bars and move it to the other side. So I see that I have a 2 and a 3 outside. I'm going to take and move these to the other side of the equation. So I'm going to start with the plus 3. I'm going to take subtract 3 to the other side. That's going to cancel, leaving me with 2 times the absolute value of x minus 8 is going to equal 15 minus 3 is 12. All right, now I have a feeling that I think some of you might be thinking, well, hey, why can't we distribute, whoopsie daisies, why can't we distribute this 2 into the absolute value bars? Okay, so why can't I distribute this 2 into the x into the minus 8? Well, the reason is that the absolute value is something that we cannot affect. We cannot touch what's inside of here. In order to figure out what x is, we need to isolate the absolute value bars so we know that we're talking about the absolute value of something equals a number. So what I need to do is get rid of this 2. So I'm going to do the same thing I did with the plus 3s. I'm going to think about what am I doing with 2 in the absolute value. When we're written next to it means that I'm multiplying together. So I'm going to take and divide 2 from both sides. What that ends up going to be doing is it's going to isolate the absolute value bars and whatever's inside, and it's going to set it equal to 6. So what I'm basically saying here is the absolute value of x minus 8 equals 6. So the end result is the absolute value of what number would give me 6. So remember, there are 2 potential things that could happen. Whatever's inside x, folks, whatever's inside x minus 8, that could equal 6, because the absolute value of 6 is 6. But whatever's inside x minus 8 could also equal negative 6, because the absolute value of negative 6 would also give me 6. So what we have to do then is set up 2 equations. So this is step 2. Remember how we set everything inside x minus 8 equal to the number 6 and its opposite, negative 6. Gives us 2 equations, and now what we're going to do is solve both. So this one should be easy. We're going to add 8 to both sides. We're going to get x equals 14. Woohoo. And this one, add 8 to both sides as well, and you're going to get x equals 2. Negative 6 plus 8 is 2. So notice solving the equations, you're basically solving them the same way both times, but here I get 2 solutions. X equals 14 and x equals 2. Both of these would satisfy this absolute value equation. All right, so let's go ahead and do a few examples here. First one, I have x, absolute value of x plus 5 minus 8 equals 15. Step 1, we're going to take anything on the outside and move it to the other side. So I'm going to take this minus 8, move it across by adding 8. It's going to cancel out here, leaving me with the absolute value of x plus 5 is going to equal 15 plus 8 is 23. Okay, then I'm going to take whatever's inside now, since the absolute value is isolated. I'm going to take whatever's inside, x plus 5. In order to get 23, x plus 5 could equal 23, because the absolute value of 23 is 23. Or x plus 5 could equal negative 23, because the absolute value of negative 23 is also 23. Then I'm going to go ahead and solve both these separately. So I'm going to take and subtract 5 from both sides. And I'm going to get x equals 23 minus 5 is 18. And then same thing here, subtract 5, and I'm going to get x equals negative 28. So I'm saying that when x is 18 or negative 28, both of these would satisfy the absolute value equation. Next one, let's go to the right here. I have 4 plus 2 times the absolute value of 3x equals 28. So this one, I am going to take and isolate the absolute value by moving everything across. So I have 4 plus 2. Remember when we're writing things next to each other, this means multiplication. So I'm going to take and subtract 4 here from this side, bring it across. That's going to leave me with 2 times the absolute value of 3x equals 28 minus 4 is 24. Okay, now this one again, I am not going to multiply these two together. I'm not going to distribute inside the absolute value, but instead I'm going to isolate this absolute value by dividing by 2. That's going to give me absolute value of 3x equals 24 divided by 2 is 12. Now, since I isolated the absolute value, I'm going to say whatever's inside here, 3x. 3x could equal 12, or 3x could equal negative 12. Both, when you take the absolute value, would give you 12. So I'm going to divide each of these. I can do these at once since I'm doing the same thing. Divide each of these by 3, and I'm going to get x equals 4, or x equals negative 4. Okay, so that means I'm going to get my two answers again right here. Very good. Next one. Oh my gosh. Everybody, let's freak out. Holy cow. How the heck do you solve this one when there's fractions? Oh my gosh. How do I do this? Well, we'll solve it the same way. Let's follow our steps, okay? So I'm going to take and isolate isolate the absolute value by moving anything that's on the outside to the other side. So I'm going to start first, like we would, and add 8 to both sides. Okay, y, again, I'm going to try and get the absolute value by itself. So I'm going to be left with negative 5 times 3 over 8x minus 1 over 6. And that's going to equal 12 plus 8 is 20. And then again, I'm not even going to worry about distributing this 5. That's just silly. Instead, I'm going to divide by negative 5 because I'm multiplying it by those absolute value bars. What I get is the absolute value of 3 over 8x minus 1 over 6. It's going to equal 20 divided by negative 5 is negative 4. So here's what I'm saying now, is that the absolute value of whatever this is should equal negative 4. Okay? So the absolute value of something, whatever that number is going to be, I know there's fractions, is going to equal negative 4. Well, wait a second. Hold on. Dang tootin'. Wait, how can the absolute value of something give me negative 4? Remember what we said, the absolute value of a number can only result in a positive value. So can this ever work out? Can the absolute value of this give me negative 4? No, because the absolute value can only be positive. So right here, there's no need to solve this. Because if I notice that the absolute value of a number is equal to a negative, I have to recognize right away that this is no solution. Why? Because you cannot take the absolute value of a number and get a negative value. It's always going to be positive. So this is one thing to notice, that if you get a negative here on the outside that's left over, it's automatically no solution because the absolute value of a number can never be negative. All right, last two examples here. I have the absolute value of 3x minus 1 equals 13. So notice this one, the absolute value is isolated already. So here's what I'm going to say, is that whatever's inside 3x minus 1, this could be equal to 13 because the absolute value of 13 gives you 13. And 3x minus 1 could equal negative 13. All right, so now I just have to go ahead and solve each of these separately. So the first one, I'm going to add 1 to both sides. And I'm going to get 3x equals negative 13 plus 1 is 14. Then I'm going to divide by 3. Oh no, 3 doesn't go into 14. What the heck? 3 doesn't go into 14. That's okay. We can have fractions, so that means x is going to equal 14 over 3, 14 thirds. That's fine. Okay, and then again we can solve this side. Add 1, add 1. You're going to get 3x equals negative 13 plus 1 is negative 12. Divide by 3. This one's going to work a little better. X is going to equal negative 4. Just to warn you guys, with some of these absolute value equations, you are going to get fractions. That's okay. Just because you can't divide 14 by 3 doesn't mean there's no solution. It just means that your solution is going to be a fraction. Okay, next one. This one we have the negative 5 times the absolute value of x plus 3 minus 3 equals negative 15. I know what you guys might be seeing. Some of you might say right away, whoa, negative on here first, right? The absolute value of this number can never be a negative. Well, here we go. First thing is I see that I have this negative 5 and negative 3. Don't see this right away and say no solution. You need to isolate the absolute value first before you start thinking about that negative at the end. So even though I see a negative 15 after the equal sign, I'm going to just still get and isolate everything else. So I'm going to add this 3 to this side. I'm going to have negative 5 times the absolute value of x plus 3 is going to equal negative 15 plus 3 is negative 12. Then I'm going to divide by negative 5. Now what happens? I get the absolute value of x plus 3 is going to equal negative 12 divided by negative 5 is going to be positive 12 over 5. So notice how originally it was a negative 15 after the absolute value bars, but once we've taken our first step and moved everything over to the other side, we end up getting a positive. So this is okay. We're actually going to have a solution. So what we want to do here is take whatever's inside x plus 3, and I want to set it equal to positive 12 over 5, and take x plus 3 and set it equal to negative 12 over 5, because the absolute value of 12 over 5 or the absolute value of negative 12 over 5 could give me 12 over 5 as an answer. So now what we've got to do is just simply solve each of these equations separately. I know some of you are probably freaking out right now because of this fraction. You're probably completely lost maybe in what I'm doing because there's a fraction there. That's okay. Here's what we'll do to make you feel happy. Let's take and turn 12 over 5 into a decimal. Divide these two numbers out. You're going to get x plus 3 equals 2.4, or x plus 3 equals negative 2.4. If that makes you happy, we can put it as a decimal. So then what we'll do is we will subtract, whoopsie daisies, gotta get my pen tool, gotta subtract 3 from both sides, and we'll get x equals negative 0.6. And here subtract 3 from both sides, and we'll get x equals negative 5.4. Okay, you can have those as a fraction or put them as a decimal. I know some of you probably would like to prefer to put them as a decimal. Okay, so again, this is solving absolute value equations. If you had any questions, make sure you jot them down. Bring them to class. This might be a little different than things we've done up to this point. Otherwise, good luck on the practice problems and good luck on the mastery check. We'll see you guys later. Peace.